Welcome back. This section in 2D, we are going to see the two modes of operation of CPU and why is it required. Before we go into that, because this course name itself says that operating systems and system software, let us understand what does system software mean. Okay. Then we'll get into the process control, the modes of execution. Then how does kernel get into kernel mode from the user mode. Okay, how do you get into a mode where the kernel software is run? Now before we get into that, what is the difference between application software and system software? As you are all aware, application software is that which runs on top of the entire system, right? Mostly the one which is interacting with the users. Now for example, this PowerPoint whatever I'm using is an application software which is facing the user, and lots of user interaction is there on this. Similar to that, even a web browser could be an application software because it's with which we are interacting, and any software that we normally interact as a software engineer, these are all going to be application software. But those engineers who understand the OS, understand the architecture, understand little bit about many of the tools that play a critical role in converting an software into an executable, they work on the special software which is called system software. The name indicates that a software which is interacting closely with the systems. That means even the operating system is a system software, and all the tools that we have come across, compiler, linker, loader, they are system software. Any software which, if suppose you are writing, then the engineer who writes those called systems engineers or firmware engineers. These people need to be aware of how operating system works, because this system software people need to understand how operating system works, and they need to work with the operating system, or even they should be aware of the CPU. How does the CPU work? And then memory, how is it memory is managed? So little bit of systems knowledge is required to develop system software, and mostly the system software are written in C because they are close to the hardware, whereas application software could be in Java or Python or any other high level languages. You could develop application software. So these are the major differences in terms of users who are developing them, or sorry, developers who are writing these softwares, and then what kind of tools they will be using, what language they write on the things, and what knowledge you need to have to develop them. Application software, mostly you need to have knowledge of database, data structures, and then GUI development, and languages like mostly object oriented languages like C++, Java, Python, and you will be developing something which is user facing. Whereas system software are one where you need to mostly develop it in C, or some part of it may be in assembly, and they are looking down into the hardware, and they interact very closely with the operating systems, and all the tools that we use for developing software, they are also aware of OS and the architecture below, CPU architecture. Now let us try to understand this application software and system software. Maybe I would like you to freeze it and think about one software that you know, any package or software that you know which falls under one of these categories that I have listed here. Try to see if you can think of some software which may be a word processor, or it is meant for graphics, developing some graphic applications. I'm not going to list out everything that falls under this category, but I will give you something which I thought of listing it here. One example each for each category. So MS Word is one, Microsoft Word. Graphics, Adobe Photoshop. Spreadsheet, again Microsoft Excel is the most popular, highly used by business people. Communications, which is related to either a serial port interface, which is a term, a terminal which connects to a COM port, or Wireshark is one which is connected to the network, which can actually look into the every packet that goes through the network, and then it gives you the content of all the packets and their headers, and even the individual elements of the headers, it can be seen in terms of time. You can log everything on the network and see. That's the Wireshark software. They are all application software, but still they are related to communications, and database is MySQL is one good example. Games, I'm sure you know more than me what all the game software that you have come across. Now, these are the tools that I mentioned. Assembler is for converting an assembly program into a binary format, which can be understood by the CPU. Debugger is one which can be used for stopping your program execution and then looking at the contents of variables or maybe even registers and the memory content, where is your current program counter is. So you can go deep into execution of the program and stop it at a time and single step it. So this is a debugger. Compiler is one which converts higher level language into a binary assembly instructions. Okay, OBJ files generate. So this is set of GNU tools can be one good example. File management, disk utilities. There are many disk utilities, maybe defragmentation or formatting a disk. These are the if you want to look at the disk content and then try to optimize the way the files are distributed over the disk. They're all utilities which comes under file management. So the tools that I'm showing below, they are all system software, whereas the ones which are above the application software. OS itself falls under this category, Linux and Windows. Bootloader utilities, which is a good example of system software because you can see that they are all close to the hardware, right? Now, let me just summarize what are system software. System software mostly interacts directly with the OS. Don't think that application software don't interact with the OS. They do. Anything to run on the system need to interact with the OS, but you will not be writing code which will be interacting with the OS. You will be using the libraries. Maybe if you are developing in a VC++ environment or Visual Studio or any of those higher level languages, you will be using either Python libraries or C++ libraries, which in turn will be using the OS facilities or services. So if you are not directly using the OS services, that doesn't mean that your application software does not need it. But system software, when you are writing, you need to interact with the OS directly because they run below. Though you may be having libraries like C libraries and other things, but still system calls you may be calling directly from your software and going into the services of OS. And you may be even interacting directly with the hardware also. So some part of it maybe you will develop it in assembly. So system software are installed on the computer along with the operating system installation. So normally they are installed along with the OS because they are tied to the OS. In general, the user does not interact with the system software directly. As a user, you may not be directly interacting with the system software and they run in the background. When this laptop is running, there are many software which is running in the background. Maybe a scanner which looks for any virus. When you are downloading any program from Google Drive, it automatically comes up and then scans the file and then it gives you a green signal that okay, this file does not contain any dangerous embedded code in it. Okay, that which can be downloaded into a laptop and then it can run and then it can compromise your system. So such things are running in the background. System softwares are normally running in the background, and it may not be giving an interface with the users. It is at the back end and interacts with the OS more than the users. So systems software can run independently, okay, without user interaction. Normally they are run as a processes, and they need to be robust and highly reliable. So if you are writing system software, you better understand the functioning of OS, hardware, CPU, and good knowledge of architecture is a must. It provides platform or helps application software to run on a processor with OS. So system software may be helping you or helping the application software to run on the system. Some examples of system software are compiler, assembler, debugger, which I already listed. Device driver also falls under this category. Now, let us list out system software, which is libraries, C libraries, and operating system. They fall under this category, and it provides the interface between the hardware and user applications. Is in between, right? So, system software includes utilities, device drivers, OS itself. But GUI is GUI sort of OS debugging tools. Many of the things also can be part of system software. System programming, developing system programs is called systems programming. Okay, this involves having good knowledge of the processor OS now on which the system programs are running. So let us identify which are the ones who fall under application software and which are the ones fall under the system software. So I want you to freeze this and write down what you think they are based on whatever I have explained to you. I'm sure you will be able to find out. In case if you make an wrong choice, let us see the reason. Okay, I'm sure PowerPoint, I have given this as an example also, so you will not make a mistake. It's an application software, of course. Antivirus, that also I mentioned it, like it scans for virus embedded into the files or anything that you, even USB pen drive you connect, it immediately scans the pen drive and looks for any virus in that. Okay, and then alerts the user. So antivirus needs to understand a little bit about the signature of the virus from the rest of the software. So they need to have a good understanding of how to look into the executable and see whether there is a embedded virus in it or not. So they naturally fall under system software. CCleaner, you might have used it in your laptop where you want to clean some backup files, or when you are accessing the internet, there are many files get downloaded without your knowledge and kept in a C drive or somewhere, some other places where the Chrome or any other browser that you are using is keeping it for its use. Okay, normally when you are looking at the browser, many files are downloaded without your knowledge, because if it has to access it every time from the web server, it will take time. So it will be copied onto your laptop so that the web uh, pages can be put on the screen, much faster, and if it is efficient when you are scanning through pages. So because of that, what happens, your laptop becomes heavier with lots of files getting downloaded without your knowledge. So the C cleaner helps you in terms of identifying those files and removing them. Of course, they need to have a knowledge of the OS, knowledge of the tool where it is keeping those downloaded files. So it needs to have some systems knowledge. So naturally, I am making you think that CCleaner is a system software. Now, what is JVM? Now, Java Virtual Machine is one where the environment in which the Java code that you write is running. Now, Java code, when you write, it's called portable language. Only the reason being, it is not dependent on the OS or dependent on the CPU on which this OS is running. JVM is running on a virtual machine which understands the Java code. And then when you are sharing your uh, Java applications or Python applications, you are not going to share the source code because you want to keep your intellectual property safe. But at the same time, you are not going to be compiling it for a particular hardware or a particular OS. Okay. Whereas if you are writing a C application, you cannot share the C code, of course. Then you will be compiling it and then generating a executable for a particular uh, system. It could be Windows based or Linux based, because executable that is built for a Windows based system will not run on a Linux based system. So it is OS dependent. And then the executable is also dependent on which processor you are developing the generator the executable for. Otherwise, it will not, even if Linux is running, underneath whatever processor you are developed the generator the executable for should be same. Otherwise, that executable will not run. Even it will have sometimes the dependency on the version of the OS that you have developed the executable for. So they are not portable. C language or C++ language executables are not portable, whereas Java is portable. The reason being, it runs in the Java virtual machine. So now, if you need to run a Java, you can just share that Java code, and then that can be run on this virtual machine, which doesn't depend on the processor. Now, JVM itself needs to have an understanding of converting the bytecodes which you are running it on JVM to equivalent assembly instructions on which this JVM is running on. So they need to have a better understanding of the language output, the bytecode generated by the Java program, the jar file you have given, and then it should convert every bytecode into a equivalent assembly instruction. So naturally, it's a system software. What is disk formatter? It needs to know how the files are stored in the disk. Okay, how to optimize it. So it of course needs to have knowledge of OS as well as the formatter, because disk file structure, so it's file dependent, file system dependent, OS dependent, and the hardware specific disk dependent. So of course it is system software. What about Visual Studio IDE front end? Front end is a GUI. Maybe most probably it would have been developed in C++ language, and it doesn't bother about what display you are writing into onto. It will be using all DC, Visual Studio libraries. So the GUI front end part of the Visual Studio mostly it is an application software. What about the backend tool chain, which when you try to compile your code, it is calling the compiler, assembler, and then linker. They are all tools. Of course, tools fall under system software. Google Chrome is a browser, so naturally it's an application software which is user facing. And a task manager, when it is run, it has to understand what are the processes running, how much of memory it has consumed, how much of time it has been running on the CPU, when it was created, who is the owner of the task processes. So they need to have an understanding of the OS. So task manager, of course, is a system software. So I hope all of you understand the distinction between these two categories of software. You may have interest for any one of them. Both are good to have, and you should know what knowledge you should have to be a successful application engineer or a system software engineer. Fine. Now let us look at the modes of execution. Now I told many times that OS is very very critical software and which is running on the hardware. So application software is on top of it. Now when the OS is running, it is a special software. It has a special permissions compared to application software. That means it should have some access to the hardware or the instructions supported by the hardware, or some part of the memory. They need to be having access to any part of the memory, as well as its own code should not be accessed by user applications. No, I told you that main memory is being shared by OS as well as the application software running on the system. Your own program is also sitting by the side of operating system in the main memory. Now what if I have a pointer, in case if I know where the OS code is, if I initialize my pointer to that, and if I try to go and modify the OS code, I can do it intentionally. But OS should be alert, it should be alert, and it should prevent such activity happening. Now, how can it be sure that this does not happen? Only when the application softwares do not have the rights similar to what the OS has. In that case, it can have some special protection against anybody trying to manipulate the OS code or OS data. That's why there is a need for two modes of operation at least in a CPU. Now, what are they? They are called user mode and kernel mode. Continuing with our discussion on the way in which OS manages processes, we need to distinguish between the modes of processor execution normally associated with the OS and user programs. Now, most processors at least support two modes of execution, and I'm sure the modes are called user mode and kernel mode. User applications run in this mode, and libraries or any system software run in kernel mode. So as I told you that OS is a software, they run in a special mode which is called kernel mode. Now who is deciding the mode of operation of the CPU? Of course the CPU. Then where is it maintained? It should be maintained in the hardware on the CPU itself. Okay, it cannot be in the software, because finally whatever program you write is it is executed on the CPU. While it is getting executed, the CPU can be in two of the modes. Okay, and if it is in kernel mode, CPU allows you to execute some instructions which are protected, which are only executable, only can be operated. No, that those instructions can be executed only in the kernel mode. So in this way, what happens is CPU makes sure that reliable software only gets into the kernel mode, and in the kernel mode, it gives you the freedom to uh, execute any kind of instruction that CPU supports. CPU may be supporting hundreds of instructions, but not all the instructions can be executed by user programs. So let me explain a little bit more once I go deeper into that. So application software and system software, they run in two different modes. That's the thing I want you to remember. Now the many processors, for at least most of the commercially available processors, maintain two bits in the processor status word. Okay, processor status word is one special register where different flags are stored, okay, maintained. Based on the instructions execution, the flags are affected. Okay, suppose you are doing a add operation, carry, negative flag, no, or overflow flag, and then negative flag, sign flag. They are all there in the process status word. They get affected when you are doing some arithmetic operation. And there are some other bits which are reserved for the modes of execution of the CPU. Normally, there are two bits. Okay. In that case, there will be ring 0, which is one special mode, and that's kernel mode. And then there are other privilege modes. So now let me say this is the least privileged. Okay. Least privileged, and this is the most privileged. The innermost is the most privileged. That means they have anything that they want, they can do, okay, in that mode. Okay, anything means we think that those software is reliable and it is written by system software engineers who understand the hardware. So most privileged instructions are run in the ring 0. So if I give you device drivers, kernel software, and then system software and applications, how do you list them based on where do they belong to, okay, in terms of the privileges they have. I'm sure all of you will agree that kernel is the most privileged one, so that should be running in the innermost circle in the ring. So kernel is the one which is running innermost, which is having most privileged execution rights. Now what should be the next one? Is it system software or a device driver? Okay, anyway, at least you can be sure that application software must be the outermost one, okay, least privileged. And you need to now decide about these two, which one will be closer to the kernel. See, device drivers are the one which really interacts with the hardware, because device drivers are written by the device vendors who understand their own hardware. So they need to be closer to the kernel, because kernel is going to make use of the device drivers to interact with the hardware. So next one is device driver, then the system software comes, any tools that you can think of, then application software. You should know the order in which these privileges are given. Okay, so the less privileged one is user mode and most privileged is kernel mode. And because the processor is supporting you 4 levels of modes, we can categorize them like this. Otherwise they will be falling under one of these categories, either kernel mode or user mode. There is nothing in between. Okay, so now instruction execution, what are the advantages of being in kernel mode? Okay, compared to non-privileged. Privileged mode of processor execution normally associated with the OS. Non-privileged mode is associated with the user programs. Most processors support at least 2 modes, okay, if not 4, certainly 2. Certain instructions can only be executed in the more privileged or most privileged thing. One is, no, that would include reading and altering control registers. So there are some control registers. Suppose even modifying the mode of a processor, you need to be, no, only special entry point should be there, so that when you are moving from user mode to kernel mode, it is done by the kernel code only, not by anybody else. Okay, I cannot write a code which will access this. I know, suppose if I am aware of the processor architecture, I should be able to look into the process status word register and then try to modify the bit to from user mode to kernel mode, and then I enter the kernel mode illegally, which is not possible in the user applications. So already OS has built the code and it has made it part of the OS that only can modify the mode of the execution of CPU, not you and me who can write software and modify it. So accessing the program status word itself needs a special permission. IO instructions, like if you want to control some device drivers, fall under this category. You cannot, no, otherwise you can even access the hard disk and then boot sector you can erase it, or even OS image you can erase it from the hard disk. Then next time when you boot your system, nothing will boot. Your system will be totally useless. So even accessing the hard disk IO instructions are only special device drivers who is knowledgeable in that area should have been provided that, and they would have integrated with the OS, the device driver software, and which will be running in the kernel mode. So instructions that relate to memory management, which is very important, because any protection that I told you about user cannot access the OS code, that should be set up before even user applications run on it. So it should be done by the special software which is OS related code, memory management. Instruction related to handling of interrupts. Interrupts are very important because it can take away the control from the user, OS also, because interrupts service routines are always written by kernel. It runs in kernel mode and written by uh, kernel application or system software. Okay, so memory accesses. Another privilege that a software running in the kernel mode has is related to memory access. What all memory it can access? In the kernel mode, it has a freedom to access every user's memory, yeah, including its own memory, OS memory. And then the reason for having two modes is to protect the OS. So, if at all someone asks you, what is the need for two modes? The reason is, unless I have two modes, and then make sure that only specialized software like system software or OS software or tools which are written by people who are knowledgeable on the hardware as well as on the OS runs on the kernel mode, I will not be able to protect my system, right? So kernel mode is a special mode which is only accessible by kernel software or OS software or the system software written by people, and then it is integrated already with the OS. Okay, so that illegally someone cannot develop a software and then put it into the kernel, make it run on the kernel mode. It should be certified by the OS vendor or system vendor like a Dell or Asus or any laptop vendors. Okay, they certify the software and then make sure that they add them into the kernel mode software. Okay, that means they can be run in kernel mode. Not any user application that you can download from web can run on kernel mode. So in fact, user programs are restricted only to access its own memory. You cannot access some other user's application memory, or even of course OS you cannot even touch it. So whereas in the kernel mode, the software can access any part of the memory without any restriction. They can even write into it. They can even kill any process. Anything can happen. So how does the kernel mode is supported by the processor? I will quickly go through it. It's important. You need to understand it, but not at the deeper level of how exactly a processor is doing. So there is a special bits. I'm not talking about any particular processor here. Any special bits are reserved for that, and this bit is changed in response to certain events. Okay, when OS service is called, they can get into kernel mode. Or when an interrupt is triggered, OS routine is called and ISR is called, then it is getting into a kernel mode. So the mode is set to the kernel mode, and upon return, you need to make sure that it comes back to the user mode. So that is the responsibility of the kernel software or the device drivers or interrupt service routines. They will make sure that when the control comes back to the user mode, user application, the mode is changed to user mode, so that user again does not have any control on processors or different parts of the memory. So entry and return, one example is IA64 Intel Itanium software. They follow two privilege level, no, two bits are used. That means four levels are there. Level 0 is the most privileged. Other levels are for user modes. They categorize everything as user mode. Only one mode is given for kernel. So on interrupt, processor clears the PSR. That means it all made 0 0. That means it gets into a kernel mode, and then it returns it executes the ISR routine which is written by the OS. So you cannot modify the ISR routine, interrupt service routine with your own code. It is already supported by the OS, supplied by the OS, and it is a trusted software. Okay, it's called trust. Only trusted software can be run in the kernel mode. Remember that. So most it because it clears the CPL bits, it becomes 0 0, which is a highly privileged mode, and it moves into the kernel mode. And when it restores, when it returns from the ISR interrupt service routine, it is restored back to the original user mode. Then you don't have that access right. So when it enters the kernel mode, it executes only the trusted software. When it comes out, user applications. Okay. So moving, how is it moving? What are different ways a process can move into a kernel mode? When you are calling a system call is something interface with the OS. You want to enter into the OS services. You want to get some services done. Fopen or printf or even scanf, whatever you are doing. You are calling a system function call. When it is executing the system calls, it is running in the kernel mode. When a timer interrupt happens, it's a ISR, so it's running in the kernel mode. IO device interrupt, any key is pressed, keyboard interrupt is coming, that is the kernel mode. So these are all the different ways a user application gets into kernel mode, and then when it comes back, they are back into user mode. So these are all, if an interrupt is calling another interrupt, they will be in kernel mode. Okay, so exception is one which I like to explain here. Exception is one where it is generated by the execution of the program itself. Okay, it's synchronous because when you are executing an instruction, suppose you are trying to access a pointer. Using a pointer, you are accessing a memory which is not initialized. Pointer is pointing at some random location which is outside of your user process memory area. Then what happens is CPU gets it, the memory management unit catches it, and informs the CPU that this particular process is trying to access a memory which is not within its range. It can happen because you are not initialized your memory pointer. So illegal access or segmentation fault, such things happen. That's called exception because it is happening because of executing an instruction which is a part of your program. So this is called synchronous to the execution of the program. These exceptions are happening because of the execution of your own code, because of some error in your code, or you have made a mistake of not initializing a pointer. Whereas interrupts are one which is an external event coming and you cannot even predict when it is going to happen. So if a good example is you decide to do something at home, that okay, I want to stop reading and then go and watch movie. It's an can be called as an exception. Whereas your friend is coming and knocking at the door and pulling you out for a movie, that is an interrupt. Both are you are anyway going for watching a movie, but one is decided by you when to go for a movie, whereas friend coming and calling you for a movie is not in your control and is an interrupt. So it's external to your control. So that's a simple, good crude way of comparing the exception with an interrupt. So with this, I'm stopping here. So I hope you understood about what is user mode, kernel mode, what are application software and system software, and how does the program or a process gets into the kernel mode. Okay, bye bye. See you in the next lecture.